Okay. We've got a few admin things to do before the start of the lecture. So firstly, the catch-up assessment and the revision assessment for next week. So here on the 12th will be the catch-up for those who have missed quizzes. Quick show of hands, who has missed some of the quizzes this semester? Okay, a few of you. Have you filled in that online form yet? Okay, if you have not filled in that form, please do that by the end of the week. Otherwise, your marks will not be captured. Okay, so on the form, it has the date that you missed the assessment. If you don't fill that in, your mark does not get put for that assessment for the date. Okay, so you have to do that by the end of the week. And then for you, on that tutorial time, you'll be doing the catch-up assessment over here. Okay, so here's the scope. So it's just 4 questions. Okay, catch-up won't be too long and the revision won't be so long. So here's the scope for the catch-up. Please go through that in preparation for the quiz. So 4 questions. It's basically a mix of what we did during those quizzes. So here, finding the domain and range, like we did in that one of the first quizzes. Rules for derivatives, rates of change, like the quiz, and approximation and errors. Again, like we had in that last quiz. Okay, it will be similar to that. This will replace any of those missing assessments where you tell me the date. Okay, so again, you have to fill in that date correctly. So if you put in that you were absent on a Wednesday, right by mistake, that mark does not get filled in. It has to be those Tuesday dates where you missed. Okay, so that's for you guys. The rest of you will be doing this quiz 9 revision quiz. So this will be on the stuff from class test 1, class test 2, in preparation for the June test and class test 2. Okay, so it will be a mix so you cover enough. The way this is going to work is based on whatever you've selected here for the revision. So again, there's the list of everything we've done so far. You just select, the things that you want me to go through. I see here 22 out of the 100 have selected. You will have until the end of Friday to select what you want. From that selection, I will set up the lectures for the revision lectures and the assessment for the revision quiz, right? Because, for example, if none of you select truth tables, why test you again on truth tables? Everyone's fine with that. So here, this is just so far with 22 of you. So rate of change, that's the highest voted thing. So in the revision quiz for the written part, one of them will be rate of change because you really want to do that. So we'll pick that. And then let's say the second highest thing here is approximations and errors. So I'll put that in the written parts as well, right, to give you more practice. These things over here where, there's fewer votes, that will be in the MCQ, just as a little refresher kind of thing. So that will be for the quiz 9. Then for the, so it'll be the Tuesday, then the Wednesday and the Thursday, we will go through questions again based on the highest voted thing. So rate of change, since 18 votes for that, we'll do like 3 questions. Then the next highest thing here was approximation and errors. Maybe we do 2 questions. Okay. And then over here, like this is the lowest voted thing, we'll do like 1 question. Okay. So the structure for the revision is exactly what you vote for. Okay. So it's entirely up to you. So again, so far, only 22 out of the 100. If there's only 22 people voting, that's what we go with. Okay. So it's up to you for that. Any questions for this? All good. Okay, so again, the revision covers everything for the class test 2 and for the June test. So please check for both. So the June test is on all of this, obviously. And then class test 2, that's from the L'Hopital's rule up to the stuff we're doing today. Okay, that will be for class test 2. Any questions? All good. Okay, so if you haven't voted yet, please do that by Friday. And those that were absent for the quizzes, please fill in that form again by Friday so I can print out the the register for Tuesday. Any issues? Oh, good. Okay. So let's get on with today's lecture. This is what the second years are doing. We'll see that soon enough. So we're going to be sketching rational functions. Okay. So I did mention this before. So remember the cubic polynomial sketching, that was for the quiz, right? You saw that one in the quiz. Then for the class test, it's going to be that fourth order polynomial. For the June test, it's going to be one of these, right? We went through that. So June test will be one of these rational functions. And then for the final exam, it will either be a rational function or the fifth order. I'll pick one. I'll let you know which one it's going to be, but just to give you an idea of the difficulty. Okay, so for the class test, the fourth order, like we did last week, June test, the rational function, just so I don't double test you on the same thing. And then the final exam, it will be one of the two. Again, I'll let you know later on. Okay, so June test will be something like this. Okay, so a quick recap. What is a rational function? So a rational function f is given by some polynomial p of x divided by some polynomial q of x. Okay, so they're both polynomials. So you can have a quadratic over a cubic, quadratic over a quadratic, a linear over a cubic, something like that. So a polynomial at the top and a polynomial at the bottom. Now, with these, as we saw when we did the domain and range, there's a problem with the domain here, and that is where this denominator is 0. Right? You know, we can't divide by 0, so those points need to be removed from the domain. In terms of these rational functions, we'll see that those points at the bottom that make it 0, those will become our vertical asymptotes. Okay, so we need to add that to the list of things to find. So vertical asymptotes, we also have horizontal asymptotes we need to now add to the list. So the total list will now be x-intercepts, y-intercepts, turning points, possibly inflection points, depending on the problem. And now we add horizontal asymptotes and vertical asymptotes. Okay. So just as a warning here, wherever this q of x is 0, we get our vertical asymptotes. And depending on the order of that polynomial, we get some number of asymptotes. If it's a quadratic at the bottom, we might have 2 asymptotes. If it's a cubic at the bottom, we might have 3 asymptotes. So it depends on that order. Okay. So let's just jump straight into the first example. So number 1, we have f of x is equal to x over x squared minus 9. Okay, so right away we see it's a rational function. At the top there we have a linear polynomial, just x, and at the bottom we have a quadratic polynomial, x squared minus 9. So don't worry about all the asymptotes for now, we'll get to that later. We start at the top of the list and move down. So x-intercepts, y-intercepts, turning points, and then at the end we'll look at the asymptotes. Okay, so don't let that scare you just yet. So firstly, the x-intercepts. So that is where the y value is 0. So for this fraction to be 0, the top part must be 0. Can't have the bottom part being 0 because then we're dividing by 0. So y-intercept, we let, x-intercept, we let y be 0. We solve for x. What do we get? X will be 0. Yeah. Again, we just look at that top part being 0. So x-intercept, we let y be 0. So we have x over x squared minus 9 is 0. It doesn't matter what the bottom part is. If the fraction is 0, the top part is 0. Okay, so we get 0, 0. Next, the y-intercept. Okay, so y-intercept, we let x be 0. Again, the bottom part will just be minus 9. There's no issue with that. Top will be 0, so we get 0. So we have the point 0, 0. Again, like we did last week, don't worry about copies of the points. You just get all of the points. We'll deal with that later. So we've got the x-intercepts. We've got the y-intercepts. Okay, again, don't worry about the copy. And now we need the turning points and possibly inflection points. You might have that. Okay, so let's rewrite the function. So this will be x over x squared minus 9. And we want f prime. Okay. Now, when we find the derivative, because it's a rational function, we will always be needing the quotient rule. Right? There's always something at the top. There's always something at the bottom. So we always need the quotient rule when doing the derivative. Okay. So we've got p over q. We're looking at the derivative. Okay, so what's the quotient rule? If we have p over q, remember the thing we said a lot of times, p prime q minus q prime, right? P prime q minus q prime p over q squared. Yeah, right? So we're always going to need that, right? Because it's a rational function. So if you're making mistakes with the quotient rule, please make sure you have that written down so that we can substitute. Okay, so derivative of the top, that's easy. It'll just be 1 minus, then we leave the top part alone. And then we do the derivative of the bottom, that's just 2x. All over this bottom part squared. Okay, so that's the derivative using the quotient rule. To find the turning points, we want the derivative to be 0. Now we have a fraction equals 0. That can only happen if the top part is 0, right? So let's look at the top part and set that to 0. Then we've got the 2x squared from there. Yep. So we've got x squared minus 2x squared. Okay. Let's just simplify first. X squared. Okay. So we end up with this. Now we want to solve for x. Can we do that? No, we can't. So what does that mean for the turning points? We don't have any turning points. Okay. So here there's no solutions for x, so there's no turning points. Okay, that's fine. Now we need to look for the intervals of increase and decrease. So is it going up? Is it going down? What's happening with that? So exactly the same as before, nothing new. So we're going to look at our f prime and we're going to see, is it positive? Is it negative? What's happening with that? Now we see this is f prime. This bottom part is squared. Always, right? From the quotient rule, the bottom part is squared. So can that bottom part ever be negative? No, it's always positive. So if we want to see where is this positive or negative, we don't need to look at the bottom. It's always positive. So we look at the top. Okay, so that top part there, is it positive or is it negative or does it change sign? This top bit here. Yeah, so we got the x squared minus 2x squared minus 9. It's always negative, right? From here, this bit that we simplified, minus x squared minus 9. It's always negative. You see that? Yeah. So this top part is always negative because it's this, minus x squared minus 9. The bottom part is always positive, so the fraction will be always negative. So, here's negative, it's always negative. So we're going to see that when we sketch this, it's always going to be decreasing. Is that clear? Okay. And there's no turning point, so it's always going down. Now, there's two more things we need to add. So we're done now. This would have been done for the polynomial part. Now, there's two more things. The vertical asymptotes and the horizontal asymptotes. So let's look for the vertical asymptotes. The vertical asymptotes, as we said at the beginning, is where this denominator becomes 0. Okay, so the function's undefined, we have asymptotes there. So whatever that bottom part is, we set it equal to 0 and solve for x. That will give us our vertical asymptotes. So the bottom part was x squared minus 9. We set that to 0 and we solve for x. So this will be x plus 3, x minus 3 is 0. So x equals minus 3, x equals plus 3. We get 2 asymptotes. Okay, again, it's quadratic, so we might get 1, we might get 2. We won't get any more than 2. Okay, so 2 vertical asymptotes. Next, we need to look at the horizontal asymptotes. Now, in high school, when you did the horizontal asymptotes, you did that by inspection. Right? You had something like this. Right? Remember, you have something like that. So you had a vertical asymptote at P and a horizontal asymptote at Q. Your teacher just said that number, that's the asymptote, right? Yeah. What we're going to do now is not so simple. We need to actually calculate it. It's not just picking it from the formula. The way we do that is by looking at what a horizontal asymptote actually means. So we're going to draw a little picture on the side here. So we'll do the same sort of picture that you did in high school, but we'll see what this actually means here. So we got a horizontal asymptote at y equals q, vertical asymptotes at x equals p, and we had something like this, right? Yeah. So what does it mean to actually be a horizontal asymptote? It means that if we take our function, we take the limit as x goes to infinity, remember limits, when we take the limit as x goes to infinity, our function approaches q. You see that on the right-hand side? When x goes to infinity, y approaches q. Let's look at the left-hand side. When x goes to minus infinity, y approaches q. That's what it means to be a horizontal asymptote. It means that in the limit as x goes to plus or minus infinity, our function approaches some constant. That constant is the horizontal asymptote. So we're going to have the following. The limit as x goes to plus or minus infinity of p of x over q of x. This is going to be some constant. If it ends up being some constant in the limit, that constant is our horizontal asymptote, y equals c. So the horizontal asymptote is at y equals c. After taking that limit going to positive infinity and negative infinity, that gives us that line, y equals q there. Any questions on this? All good. Okay, so let's work it out. So let's see what our function is. f of x was x over x squared minus 9. And we're looking to see, are there any horizontal asymptotes? Maybe there's not, right? We need to check. So does the limit give us any asymptotes? So we want the limit. X goes to plus or minus infinity. We can just pick one, doesn't really matter. X over x squared minus 9. Okay. Now, what do we have here? The limits for the top part will be infinity. The limit for the bottom part will be infinity. We have infinity over infinity. What does that mean? L'Hopital's rule. Yeah. Okay, remember we did that long ago. It shows up again. So this is type infinity over infinity. So we can do L'Hopital's rule. So we do the derivative of the top and the bottom, do the limit again, and see if we get an answer. So this is going to be the limit as x goes to infinity. The derivative of the top, that's just going to be 1. The derivative of the bottom, that will just be 2x. So now if we do the limit, what do we get? 0. So we get a nice limit. So that is our horizontal asymptote. It's y equals 0. So we have a horizontal asymptote at y equals 0.
Question.
Yeah.
So during test, right? Let's say we have our asymptote is 0, right?
Yeah.
Do we gain marks for calculating it in the set as well? Or...
Yeah, you have to calculate it. Yeah. Yeah. Each of these steps is your marks for the calculations. Yeah. So like we had in the quiz, I said, number 1, find the x-intercepts. Number 2, find the y-intercepts. Number 3, find the turning points. That's where the marks will be for finding those. And then the last few marks is for sketching it, drawing it in, drawing the labels. So this will be part of the marking. So it will be x-intercepts, y-intercepts, turning points, vertical asymptotes, horizontal asymptotes. Okay. Any other questions? So you'll see in the test, I'll list it out, the things that you need to find. Okay, so let's sketch this. So we've got x and y. Okay, so let's put in all the points like we had before. So we go right to the top here. X-intercept, 0, 0, so that's just at the origin. Okay. Next is the y-intercept. Again, 0, 0, that's at the origin. We already have it, so we can leave it out. Turning points, we don't have any, so that's fine, we can leave that out. But we do need to do this calculation here to show it's always decreasing. Okay, so just because you don't have any turning points doesn't mean you stop there. Do all the calculation as we did before. Okay, so again, keep in mind, always decreasing. Asymptotes, -3 and 3. Let's put that in. Right, dotted line for asymptotes. Yeah. Okay. And then the last thing on our new list is the horizontal asymptotes. But that was at y equals 0, so that's just this x line. You don't need to do a dotted line over that, but if you want, you can do it like this. All right, if you really want, I'm not too worried about that. But we've got 2 vertical asymptotes, a horizontal asymptote. Now we need to put in the graph. Okay, how do we do that? Well, this is our big hint over here. It is always decreasing. So whatever we're sketching, when we draw with our pen, it must always go down. If your pen is ever going up, you're doing it wrong. Yeah. So from extreme left to extreme right, the pen must always go down. Okay, that's the big hint for sketching this. Then the next hint is this asymptote. Our curve, whatever it might be, always approaches the asymptote, right? When you do the limits, it approaches. So extreme left to extreme right, it's always going down and it is approaching the asymptotes. Okay. So let's keep those two things in mind, and we're going to try to sketch this. Okay. We're looking at the extreme left. If we try to draw it in the top, is that possible to always draw the curve going down if we're in that top part? No, because we've got that asymptote, we'd have to draw up. So that doesn't work. Now we look at the bottom part. Can we draw it going down? Yeah, we can. So it's going to look like this. And I'll put little arrows here so you can see the pen direction. So we're going along the asymptote, always going down. So we're going along the asymptote. We hit the vertical asymptote and we need to go down. So we follow that there. Next part, we are in between the two asymptotes. And again, the pen must always go down, always. But we also need to pass through that origin. We have to. It's one of the intercepts. So how do we do that? Well, yeah. So we've got the asymptote. It must always be along the asymptote. It has to pass through that point, and it has to go along the second asymptote. There's only one way to do that. So it must always go down through the point, and it must always go down. There's only one way to draw it always going down in that way. Again, arrows for the pen direction. It is always going down like that. Okay, you can think about it. There's no other way to do that. Okay, if you're going to draw a line going down, passing through that point, this is the only way. Okay, and then finally, this last bit, after 3, again, it's always going down. So should we draw it in the top part or the bottom part? The top part, again, because the pen must be going down. So again, we start at the top, we follow the asymptotes all the way down, and again, follow the asymptotes going to infinity. These arrows you don't need to draw, that's just so you can see the direction. If you want to draw them in a test, that's fine, but not needed. Okay, we end up with this bit of a mess over there. All right. Any questions for this one? Yes. Okay. Good question. So remember in high school when your teacher said the line can never cross the asymptote? Forget that. They lied to you. A while ago I said, forget about what you did in high school, right? It's because your teachers kept lying to you. An asymptote does not mean the function always crosses. Yeah, that was a lie. An asymptote is the limit of the function at infinity. So over here, we took the limit as x goes to infinity, right? To get that asymptote. Does the limit care what is happening at x equals 0? No. The limit is at infinity. It doesn't care about x equals 0. The function can cross the axis as much as it wants. The asymptote is at infinity. Okay. Very good question. We'll see that happen quite a lot. The function can cross the asymptote like this. It can cross the vertical asymptote. It can cross the horizontal asymptote. But in the limit, it must approach the asymptote. Does it make sense? Okay. Please forget about what your teacher said about, oh, it can't cross the asymptote. That's rubbish. It works in this case. Right? Your very simple 1 over x hyperbola, it works. It doesn't cross the asymptote. At university, they look a bit more scary. It can cross the asymptote. Yeah. So please forget what your teacher said. Asymptote is only what happens in the limit. Limit on the right and limit on the left. Yeah. Is that clear? Yes, no, partially. Okay. We'll see in the other examples. Okay. Number 2. Just in terms of the difficulty levels for when you're studying, this is difficulty 1. Yeah, no, just to give you an idea, you know, the what do they call it? Beginner, intermediate, advanced questions. This is a 1. Okay. Okay, I think a lot of you suddenly woke up. Okay, so we've got, this one is like 2. Okay, so x plus 4 over 4x squared minus 4x minus 8. Okay, so the reason this is a 2 is the bottom is a bit more complicated. So here for this first one, right, x squared minus 9, easy to factor. You can do it very easily. This one, a little bit more complicated. It's not as easy as the first one. Okay, let's go through the steps. So x-intercepts. Okay, so how do we find the x-intercepts? We let y be equal to 0, solve for x. Again, we've got a fraction being equal to 0. Well, the bottom part has nothing to do with that. It's just the top part that must be 0. So x plus 4 is 0, so x must be negative 4. Okay, 1 mark, done. Y-intercepts. Okay, so for y-intercepts, we need to let x be 0. So that's pretty easy. So if x is 0, y will be? Was it? Negative a half. Right, you just put in your calculator and check that. Okay, so y-intercept done. We got 2 out of 10 or whatever it is. Okay, next, turning points. Okay, so we've got our function, f of x is equal to x plus 4 over 4x squared minus 4x minus 8. Okay, so for the turning points, we want to find the derivative. That will give us our tangent lines. Set it equal to 0. That gives us the turning points. And again, it's always going to be some kind of quotient rule, right? Because we've got this top polynomial and this bottom polynomial. Okay, if you don't know the quotient rule, you can't continue. Okay, so derivative of the top, leave the bottom alone. Minus, leave the top part alone, derivative of the bottom. All over whatever that bottom part is squared. Okay, and we want this to be 0. So the bottom part doesn't play a role. If this is to be equal to 0, that top part must be 0. Okay, so let's write that out. Then we can expand that there. That's a closed bracket there. Okay. So we want to simplify this. It's going to end up being a quadratic. So we might have 2 turning points. Right? We might have 1, 2, no turning points. But let's simplify this, see what we get. So 4x squared minus 8x squared, so minus 4x squared. Okay, next we got minus 4. Then we've got a minus and a minus, so that's a plus 4, so that's going to go away. And then a minus 32. Okay, then we've got a minus 8 over here, a minus, and then another minus, so minus 8 plus 16. What's that going to be? 8. Okay, it took too long. Yeah, we end up with this. So here we need to check, we might get one turning point, two turning points, no turning points. It depends on this. Okay, so quickly check on your calculators. What do we get? $0.24. Okay, let's put that in here. Minus 8.24. Okay, everyone get the same thing? So these are the x values for the turning points. Now we need to find the y values. So y equals. Okay, so we put it back in the original function we had up here. What are the y values? Right. Yeah. Negative 0.4. Okay. And then the other one. Yep. Negative 0.01. Like that. Everyone else get the same thing? Yes. Okay. So we have our two turning points here. Now we need to see intervals of increase and decrease. So, what's happening between the turning points. Okay, so we've got two here that we can look between. So the first one, minus 8.24, somewhere over here. Other one, somewhere over there. Okay, so before the first turning point, we need to see is it going up to the turning point or down to the turning point. Then between the turning points, something's going to happen. And then after the last turning point, something will happen. Okay, so let's check to the left of the first one. So substitute into the gradient, and we need to see is it positive or negative. Minus. Positive. Negative. Yeah. I'm hearing positive, negatives, and confusion. Negative. Is everyone getting negative? Okay, let's go with negative. Okay. So it's going down to the first turning point. Okay, what happens between them? Positive. Okay. And then after that second turning point, Negative. Everyone get negative? Okay, good. Okay, so it's going to go down to the first turning point and then back up. So it's going to be some minimum there for the first one. Then for the second one, it's going to go up to the turning point and then back down. Okay, so when we sketch that, we need to keep that in mind. Next, we need the vertical asymptotes and the horizontal asymptotes. Okay, so for the vertical asymptotes, we go back to our original function. We see this bottom part here, that's our Q. When that is 0, we have an asymptote. Okay, so just copy that denominator. We can make things a little bit easier. We can factor out the 4. Yeah, a little bit easier to work with. What do we get? 2, -1. Yeah. Yeah. Everyone agree? You got that? Yeah, good. So we've got these two vertical asymptotes. So the graph is going to be somewhere between those. Next is the horizontal asymptote. Okay, so we want the limits as x goes to infinity of whatever our function is. So that was x plus 4 over 4x squared minus 4x minus 8. Okay, I'm not going to go through that whole thing again, L'Hopital's rule, all of that. So let's do the derivative. Okay, the top, that will be 1. The bottom, that will be 8x. That will be 0. Okay, right. I'm not going to explain all of the steps for that. Yeah.
Yes, it's also be -2 anyway.
He said 2 and -1.
So -2 and like sind wir -x -2.
You sure? Okay, he's pretty confident. Okay, no worries. Okay, we all clear on the 2 -1. We all clear with that. Okay, good. So horizontal asymptotes at 0. Okay, that's fine. Let's put it all together. Okay, let's put in our points here. So x-intercept, so that's where this top part here is 0. It'll be -4, 0. So let's put that in. Okay, so we need to cut through at that point. Y-intercept, that's where we let x be 0. We got -1/2, so it needs to pass through that point. Okay, so we're going to see it's going to like cut through something like that. Next one, turning points. We got 2 of those. So 0.24 minus 0.49, that'll be somewhere here. Let's move our label that's in the way. Okay, somewhere there. Okay, it's pretty much in line with that y-intercept, slightly above. Okay, so we got that turning point sorted, and then the other one at this one over here, minus 8.24 and minus 0.01. That's going to be on the left somewhere. somewhere over there. So we've got the turning points, we've got this x-intercept, we've got this y-intercept, and then another turning point. Okay, let's put in the asymptotes. So we've got two vertical asymptotes at -1 and at 2. So let's just cut through here. Okay, so that's our first asymptote on the left side. And then the other one at 2, so that will be on the right side after our turning point here. Okay, the labels are a bit annoying, but it cuts through over there at 2. Okay. Everyone clear so far with all the points? Okay. Now we need to connect the dots and remember what happens with the asymptotes. So we've got this horizontal one. Just keep that in mind there. So it needs to go along the horizontal one and along the vertical one. So it either goes along and down if it's decreasing, or along and up if it's increasing, like that. Okay. And then on the other side as well, it's going to be down the asymptotes and along if it's decreasing, or we're going to be at the bottom, we're going to go up and along if it's increasing. Everyone clear on that? Yeah. So let's go over here and check. So on the left side of the first turning point there, it's going to be going down to the turning point, and then up again. Okay, so here it will be decreasing, increasing, and then from the second turning point, it will be decreasing again. Okay, so let's try sketch that in here. Okay, so we've got this turning point over here. Again, on the left side of the turning point, it is decreasing. And then it must be increasing. So how's that going to look? Decreasing down. And then after that turning point, it must go up through that x-intercept and up. So how's that going to work? You need to picture it in your head so you can see. So we're going to go down to the turning point along the asymptote going down, right? So something like this. Well, let's put in a different color, so it's going to go down to the turning point. Yeah. Then it's going to have to go up. So try to draw that a little bit better there. The problem is the scale. It's not so great. And then up. Do you see roughly down and then up again? So it's going to go down to the turning point. Once you hit the turning point, you must start going up. Do you see that? Okay. And if it's going up, it must then go towards the asymptote, like that. Okay. Then the next one, it must go up, and then to the next turning point must go down. Okay, so it must go up. So we have to start at the bottom, right, to go up. Everyone see that? From the bottom, we need to go up to the turning point, right? You have to follow the asymptote, right? So you go up to the turning point, and then after the turning point, we must go down. And again, the asymptote is there, so you must follow along with that. So we went up, there's our turning point, then down. Is that clear? Okay. And then that last bit there, what are we doing? We're going down. So how do we go down? We're going to do the bottom bit or the top bit? Top bit, yeah. Right, because we have to go down, right? Take a look at this over here. After this turning point, it must be decreasing. So how do we draw a line that's decreasing? You have to start at the top and go down. Does everyone see that? So we start at the top and go down. If we start at the bottom, we're going upwards. That's increasing. We don't want that. So it's decreasing. And then you just go along that horizontal asymptote. And then this answers your previous question. Again, we cut through the point there, but that's fine. The only thing is the function must approach the asymptote at infinity. So that infinity in the positive direction, it's approaching. Infinity here in the negative direction, it's approaching. What happens in between there, it doesn't matter. Yeah. Any questions for this one? Yeah.
So what's going on that?
Well, it does. It's the guide for the pen. It must go along the asymptote.
Going on.
Yeah, this is dotted one here. This line. Right, because we go along, so we go down. But where do we go down to? We go down to the asymptote and along. And then the same thing for this side here. It must go along the asymptote. It's the limiting behavior. Right. Any other questions? Oh, good. Okay. Let's give you one homework problem, and then we'll carry on with the rest tomorrow. So we got something like that. It's not too much more complicated than what we did in class. But you'll see there's more of that crossing with asymptotes and stuff. Also, just a reminder, removable discontinuity. Just as a little warning, that will show up in your calculations. Okay. So this function has a removable discontinuity somewhere. You'll see it in the calculations. You need to be careful with that point. Okay. Any questions about the homework? Okay. And again, be careful with that removable discontinuity. When you're sketching that, it must be that open circle. Remember from way back, there needs to be the open circle there. Yeah. Any questions? All good? Okay. So the next few we'll do tomorrow. And then remember, next week, the quiz will be the revision quiz for those not doing the catch-up. And then if you are doing the catch-up, please do the catch-up. You can't come to me afterwards and say, oh, so I did the wrong one. Okay. Please make sure you're doing the right thing next Tuesday. Any questions on that? Oh, good. Okay. I'll see you tomorrow.